Okay, so this is a presentation about white light. Game I released 2.5 years ago. Actually, hang on a minute. I need an extra prop. Hang on a second. That's better. Extra prop that Zoom has mirrored. Okay, so I'm going to go into a bit of history behind the game, some of the tech in it, and a bit of a kind of brief post-mortem, what worked, what didn't. So, quick thing about me. As I've mentioned in my introduction, I'm the token young person. I first got my Beeb in late 1990 when I was 3. So I initially started with emulators, starting with BM in 2001, and I've released several games. So got Rupture on the Lost Realms, which I wrote the engine for. They're the hard Harry games, which were written more as an exercise, see how quickly you could write a game. And there's Tube, which didn't really work as a game, but I released it and it looks pretty, so it goes on the slide. So the original intended design was the game's going to be a spiritual sequel to Firetrack. This was actually suggested by a then young Dave Moore, who suggested the name White Light on the basis that Firetrack was all about finding the white light. So the name kind of comes from there. So it's vertical scrolling shooter, mode 2. I decided early on this was going to be a multi-load game. Firetrack had to fit everything in a single load, so it ended up with a very repetitive set of backgrounds and sprites and stuff. But because this is multi-load and we've got disk drive, we can have, in theory, new graphics every level. I did consider doing a tape version, but it was a pain in the arse and didn't end up bothering. So music was also a requirement. Firetrack had music, so I couldn't leave it out really. The other thing was to have enemies that were kind of tied to the level design. On Firetrack, the enemies just kind of floated on top with a few set waves which effectively appeared at random throughout the levels. So it was a bit like playing Space Invaders on top of a scrolling background. So I wanted the enemies to actually appear at set locations in the level. And also wanted there to be power-ups, because you got to have power-ups. Power-ups are fun. So, I mean, this took a while. Bit of a stop-start development. So I started it in late 2008. And the original plan was it was going to be a platform game. So I originally wanted to try and do 8-way scrolling, but my initial attempt didn't work out, so it kind of became 2-way scrolling, or 1-way scrolling, just vertical. So it ended up being a shooter. And I kind of kept on with this till middle of 2009. So it got shown as a couple of shows, kind of just stopped. My mental health was not good at the time, so it didn't really go anywhere. So I did pick it up again for a bit in 2013. And then in 2016, I decided, sod this, you've got to get this game done. So I got around to doing some programmer art and started seriously developing the game again. And finally also was linked up with an artist, John Blythe, who did a lot of graphics for me. And graphics actually look quite good, unlike the stuff that I did. So that's kind of an encouragement, and this eventually got released in November 2017. So that's kind of history of it. Technology-wise, a few challenges on it. So the big one was scrolling. I'm calling this a challenge. Firetrack has already solved it, but so I might as well describe it here as well. So for smooth scrolling game, you want pixel level scrolling. You know, if you're having kind of the scrolling in big chunks, it doesn't look very good, doesn't feel very good. So the CRTC chip on the Beeb you can scroll by changing the starting address of the screen, but as a chip, it's designed to do kind of character-based displays. and Beef just kind of hacked it into doing a bitmap. So you end up, if you just scroll by moving the start address, you are going up and down by 8 lines at a time, which isn't very good. There is a kind of there is a register called vertical adjust register on CRTC. It's register 5. That's used to compensate for when your display needs a length which isn't a multiple of 8 lines. So on a PAL TV, you need 312. And so you work around this by having this vertical adjust, which just adds a few lines at the very start of the display, just to make up the numbers. So in theory, you could use that to move the start display up and down 1 line at a time, but we still need to maintain a constant display length of 312 lines, or your TV goes funny. Also, it'd be nice if we could have a static status bar. So if you have a bit of the screen which doesn't scroll. Firetrack didn't have that. So Firetrack just had a small scroll display in the top left, and it glitched every now and again. It wasn't perfect. So to achieve all this, we use a technique stole from the Amstrad guys called Rupture. And this is basically a way of tricking the CRTC by programming 2 frames. So the chip thinks there are 2 frames, but we're only actually putting 1 frame to the display. So we program it so you've got your first main display. First frame is the main game display with your vertical adjusting it up and down as necessary for scrolling. And then that frame ends without turning the display off or going to blanking or vertical sync or anything like that. And then the second frame has a vertical adjust which cancels out the first one. So you can still end up with your 312 lines. And then just displays the 1 character high score display. So in order to do this, we need to reprogram this chip mid-frame. You don't need amazing timing for most of it, but you need reasonably good timing. Otherwise, it will already have gone past where you need to reprogram it. So we use a timer interrupt, so we can run code at the appropriate time in the display. And that usually involves kicking out the OS, because the OS timing routines would cause havoc with it, so we turn them off. So we end up with the kind of display in this picture. So you can see we've got our main display. So we start at the top with vertical sync. You could put that at the bottom, but I put it at the top here because it's easier just to read it. At which point we program it to have the main display of however many characters high that is, and also no sync. So the CRT won't retrace back to the top once it's displayed this bit. We also turn on forced blanking, because if we didn't, where we're doing this vertical adjust, you'd see kind of lines bouncing at the top of the screen. It wouldn't be very pretty, so we just blank those out. And so we then set our first timer to occur just before we want the display to start. And in the routine for that, we turn this forced blanking off, and you get display with all the kind of junk bits at the top hidden. And we set a second timer from that for just before the end of the main display. I think it's something like 16 lines above. And in that one, that's actually just game processing. I'll come back to why there's that second timer exists, but that's there in the game, but it's not strictly required for this. But that sets off the third timer, which occurs somewhere in that score display. Doesn't strictly matter which line, just as long as it occurs before the end of it. And then on that RQ, we set the actual display height's 1 character because that's how high the score is. And then we also program it for VSync so that the electron beam will go back up to the top, basically. And so that gives us nice smooth scrolling display. That's the easy bit. The hard bit is we want to draw sprites on top of this, and this is a bit of a pain with CPU time and memory. So initially, I went with 4-bit per pixel sprites, so basically all colours in mode 2. So 16 colour display, there you've only got 8 colours because it's a beeb. You've got full masking so that they so that you can nicely see through the transparent parts of the sprites, and we store the background before plotting it, and then when we want to erase it, we copy the old background back from that store. This is a nice idea. There's a few problems. So firstly, the masking got dropped because it required more memory. And I mean, if we go back to an early slide, so if you see the ship at the top left, it's kind of got this uneven black border around it, and that's very much the cheating masking. Rather than masking every pixel, we mask a byte which has 2 pixels in it. Because it's not very accurate, you get this kind of black border, which looks a bit rubbish, but we could have lived with it. The other problem was the background store. Firstly, that needed memory, and secondly, there was a problem with ordering. If you wanted this to work properly, you have to draw all the sprites in a given order and then restore the background in the opposite order. Otherwise, you will get phantom bits of sprite all over the screen, and it looks horrible. So I ditched that, and for a bit, I had this routine which would mark out of the various tiles, background tiles on the screen, we'd mark out which ones had sprites drawn on top of them, and would just redraw those background tiles. And that solved these 2 problems, but it's quite slow. There's quite a lot of overdraw. It didn't work too well. So we come up with a new approach, which I stole from Firetrack. Because to be honest, Firetrack made all this work, so why not steal what they did? So instead of having the full 4 bits per pixel for your sprites, we take the 4 bits which are on the in the screen buffer, and we split them in half. So the bottom 2 bits are used to store the background color, and the top 2 bits are used to store the sprite color. So this makes things like sprite plotting fairly easy. You just replace the top 2 bits and leave the bottom 2 bits alone. That gives you sprites, that gives you proper masking for free. You can draw sprites and erase sprites or whatever without affecting the background at all. And it uses less memory because you're down to 2 bits per pixel for tiles and sprites. This obviously has an effect on the color though. So you end up with only 4 colors in your background, and in sprites, because you need 1 color for transparent, you have 3 colors, which leaves you marginally better off than you were if you're on mode 5. So to make this work, you need to program your palette nicely for this. So if you've got a set of background colors and a set of sprite colors, you basically have to order the palette in such a way that if the top 2 bits are 0, then you use the background colors. If they're not 0, then you use those to use the sprite color. This effectively gives you 2 almost independent layers you can play with. And for the hell of it, here's some code. Here's what it ends up looking like. So for plotting, you pull out your sprite data. White light ends up kind of interleaving the background and sprite data in a byte, so you need to separate it out when plotting. So it's basically a load. You mask off the background bits, so you just have the sprites, and then you just OR it into the screen. technically you get maybe an issue from this when you have two sprites that overlap. They might get the wrong color, but in practice it doesn't really matter. It doesn't happen often enough. And then for unplotting, you just mask the sprite bits off. The one bit which became more complicated is when something's been shot, it flashes white. And so you kind of have to reconstruct a mask from that. And that used to be free with the old method because you had a separate mask. Instead of having to use a lookup table to get that. And these were all unrolled as well several times, so it goes at reasonable speed. But certainly that ended up working reasonably well. The other thing which I did was you don't have enough time on the beep to plot a load of sprites at 50 frames a second. It's just not fast enough. So I did try having separate time slices. So, you know, if you had 12 sprites on the screen, you plot 3 of them per frame. But it's a bit iffy, it doesn't work too well, and I've still got lots of slowdown. So what I ended up doing is the sprite plotting effectively runs as a background process. So what this meant was that everything that's not an enemy sprite, so player sprite, bullets, stars, all game logic runs in an interrupt routine. So that's actually the second interrupt routine in the picture from the other slide, the one which didn't seem to do anything useful. It's triggered there, mainly so that it occurs just after the player sprite has been drawn by the CRTC, so we can then erase it and replot it, and you never see any flicker. But basically, those will happily run in an interrupt routine every 50th of a second, and then when that routine is not running, we will effectively be rerunning the sprites, erasing and plotting in the background. With every time this goes around, it picks up a new set of sprite coordinates off the other routine. So this is concurrent programming. So I had to have some kind of basic form of mutex. My basic form of mutex was turn off the interrupts that triggers all the 50 hertz processing, which is crude, but it works. Must be slightly more magic because you can't stop the other interrupts from running, otherwise the screen might glitch. So there's slightly more magic, but not much more than that. And again, I think Firetrack actually does this, and Zalaga. So on those games, you have the same thing as White Light, where the update rate of the enemies will vary depending on how many are on screen. But if it's good enough for Orlando, it's good enough for me. I like my own sound driver. So this gives you kind of 3 musical voices plus drums with noise. But drums use the noise channel and will occasionally override one of the tones as well. So this driver's got a number of instrument definitions. So there's a frequency pattern, so you can have things like vibrato, arpeggios, that kind of thing. And there's also a very basic envelope. I think it just immediately has an immediate attack to 100% and then just has decays from there. So there's nothing fancy. There's also sound effects which overlay one of the voices. And you can hear this quite obviously in game. I think on the first level you don't notice this, but on the next 2, you'll find the background chords will get obscured by sound effects. And because you're shooting all the time, that means you never hear the background chords, which was a bit annoying, but oh well. And it also supports voices which are driven by software. What I mean by this, and why we might want to do this, is the Beeb sound chip has a fairly limited frequency range. So I mean, for high frequencies, it's fine. If you want bass, the lowest it will go is about an octave below middle C, which isn't very low at all. So as a result, most Beeb music tends to sound pretty tinny and not very good. So the way I work around this is to generate the bass tones in software through a method which is basically very low frequency sample playback. So for whatever voice wants either bass on, we program it to maximum frequency, so we get a nice standing wave, which can then be controlled by the adjusting the volume. And we can basically directly play a waveform out through that. And because because we're basically using square waves at quite a low frequency, you're basically turning this voice on and off about 100 times a second, I think, at most. So that gives us a nice way to do bass. For extra effects, for extra fanciness, we can change the duty cycle, which you can't do on the sound chip normally. So instead of having a timer period which is the same for both the positive and negative states, you switch between two periods, so you get a nice non-even duty cycle. And this is used extensively in white light. So the bass lines on, I think I put in game, I think it's on every tune, uses a 25% duty cycle, which just gives it a slightly nice non-BB kind of sound to it. And because it's so low frequency, the CPU usage is minimal, 2%. I think I measured it as. For the intermission, high score, and completion tunes, because there's not much going on the screen, we have an additional effect, which is pulse wave modulation, which is basically the duty cycle varies over time. So that gives you kind of a C64 SID type sound, which does have somewhat higher CPU usage. And because you're now rendering two voices, we use two VIA timers on the VIA chip. So you now can't really run any of the fancy display stuff. So on those screens, there's no scrolling going on. It's just a static screen with some stars going by. Yes, the enemy routines were mildly fancy, and there's frankly no good reason for this. I just thought it was clever. So they use a kind of cooperative multi-threading system. This is something I basically stole from the Sales Curve, who implemented this as a UFO system on things like Silkworm and Swiv. I think if you saw on the chat, I think Charlie has worked with this in the past. I think he may have mentioned it on Retro Software at some point. Basically, the setup is, for every enemy, you have an X and Y coordinates, just fixed points. It's got fractional as well as integer parts. You've got X and Y differentials, and you've got acceleration. And we also store a return address. So what this basically means is that when an enemy is spawned, which is spawned from the level data, we will then call into the enemy handling routine, which will set up some variables, and then it will yield. And the enemy system will let it yield for a number of frames, at which point it can be called back in, and you can update things like change acceleration or direction, or have it shoot at you, or have it just randomly explode for no reason. And this is mainly a convenience thing. I'm not 100% convinced this was actually worth the engineering effort, but it was fun to implement. So it's a slightly more solid example. So for a basic example, this is an enemy which comes accelerates on top of the screen, slows down, shoots at you, and then comes back up. So it's very simply, we set the differential so that it's going down 4 pixels a frame. We set it to accelerate. We set the acceleration upwards by, I think that's 1/8 of a pixel a frame, and then we run that for 32 frames. At which point it's reached the apex of where it was going. It's basically not moving on that frame. At which point we have it shoot straight down, and then we just have it run forever. At which point it will go off the top of the screen and we'll automatically get rid of it. Or maybe the player shot it by that point. And just another example, this one is just one which just gradually comes down the screen, kind of tracks the player left and right. And this again, this is basically sets it up with a random horizontal position, and then it goes into a loop of yielding for several frames, adding a random offset onto its current position, comparing that with the player, and then based on that, setting it to go left or right appropriately. And the random bit just means it jitters about a bit rather than just zooming straight onto you and locking on immediately. And if anyone's interested, this is the memory map. So on 32K machine, half the memory is gone already by the screen, just shrunk to 128 pixels wide for memory reasons, plus it makes it look more arcadey. Then you've got about 8K of code. Graphics take up only about 2K. There's not enough room for a huge number of background tiles or sprites. And then you've got the enemy pattern data, which is a K and a bit. And then you've got the actual level map, which is 2.5K, something like that. And then down below, you've got things like variables, you've got the music player, you've got the occasional bit where we've let the OS in, mainly so the disk drive can work. And of course, this is a beep, so of course this is not enough memory. There's never enough memory, it's only 32K. So there's several ways to work around this. The level data is doubly compressed. So initially I just had a kind of run length encoding, which worked well when I was doing the levels because they were nice and basic. But then John Blythe came in and made the levels look a hell of a lot prettier, which also meant that they didn't compress as well. So I had to implement a kind of LZ77 alike thing, which is basically a sliding window, so you can reference data shortly backwards in the data stream, and that got down roughly enough. Sprite and tile data is all interleaved, which works reasonably well because it's all 2 bits per pixel, glossing onto a 4-bit screen, so you'd have to expand it anyway. So that works okay. Variables in the stack. So I think about a third of the stack is gone. And also the very initialization bits of code get overwritten with variables as well. It's typical nasty code size tricks. So there's kind of things like on the end of routines, replace returns with a jump. Replace jumps with a conditional branch if we know what the condition is. Lots of refactoring, so random subroutines which just bring out random common bits of code which otherwise don't make sense. It makes the source code look an absolute nightmare, which is probably why I've not released it, but it does make it smaller. And then there's some nasty evil filing system stuff which I got told off for over and over. And so I should probably go into that because that did cause some problems. So basically, white light uses all memory from E100 upwards, but we need to call back into the disk system to load new levels. So what it does, if page was at E100 when the game loaded, we will just do nothing because it's fine. If it's not, the game will assume it's on a BBC B with standard DFS. And what that means is when it comes to load something, when the game starts running, it will switch to the tape filing system. And then when it wants to load something, it will clear out chunk of memory. I think it's E100 to 1200, call style disk, and then try and load stuff. And this worked great on a disk drive. Unfortunately, it does not work on an MMC. I mean, I'd implemented this on Vecton, and it was fine then. That was back in 2010. By the time White Light came out, MMC stuff was a lot more common, and I got a lot more complaints. So I think the rule became, if you're not running it on 5.25 inch, you need a master, which is less than ideal, and something I'm not going to be doing again. And we also had a tooling wise, we had this nice level editor. was implemented in Windows. It directly uses the Win32 APIs, which was a mistake because it meant it was a nightmare to code. But it does work. You can find levels, you can find enemy patterns, you can redraw sprites and tiles to find palettes. Did have the nightmare situation when I first sent this to John. The file save as option was implemented. The file save one wasn't. So we lost the first day's worth of work. Thankfully, I fixed that quickly. So what the game actually ended up being, compared to the initial design, I ended up with a system where we cycle through three levels. So you have a space level, a kind of planet level, and then a fleet level, and we cycle through those 4 times. So that gives us 12 levels. There's also a fire track tribute level halfway through, and there's also a final boss level. So there's 14 levels in total. 16 enemy types, and we also have 4 levels of power up, which is also, we can also have normal and spread shots, which I thought was it's basic, but it works reasonably well. For a baby game, it's reasonably fancy. And then comes the postmortem. So I think the tech side worked okay. I think it's reasonably impressive, looks reasonably good. Though we did end up with some quite technicolor color schemes in order to try and make it readable with the BBC palette. And I think the sound was also worked quite well. I think this game's probably too long. We could have dropped one of those 3 level cycles, I reckon. And I think possibly the levels themselves were too long and could have been shortened by about a third. There's not a lot of variation in the enemy patterns in the end. I had intended that part of the levels would be, the enemy code would be as part of the level definition, so you could have new enemy patterns for each level, but I was frankly sick of the game by the time I started looking at implementing that and didn't bother. So there's only 16 enemy patterns in the whole game, which is a bit repetitive. And also, I think you have the same enemy sprites throughout the game, which again, bit on the repetitive side. The difficulty, I think there's some contention over this. I mean, my view was if the game was easy, there wouldn't be much point to it. So the game is moderately difficult. So I think the idea was to gradually ramp up the difficulty over the first 3 levels. I mean, the first level you can mostly complete by holding down the fire button and not moving. But I think some of the feedback I got is it's probably still a little too difficult. I'm only aware of one person who's actually completed the game, which is possibly not ideal, but it's just how these things go sometimes. Though I think the difficulty did benefit from having quite a bit of external testing before the game came out. So, I mean, the original was even more difficult than what the game was eventually released as. And of course, we've got the evil filing system code I mentioned, which I probably shouldn't have done. But then I'd have to find half a K from somewhere. So yeah, I'm thinking reasonably well. It seems to get received reasonably well. So it's a nice 94%. Which I'm happy with. And yeah, so that's the end of my slides. So are there any questions?
Are you any good at the game?
Sorry?
Are you any good at the game? How far can you get into it?
I tried playing it last night for the first time in ages, and I got to about level 5. Out of 14, which I think wasn't bad given I don't think I've played it since I released it.
It's absolutely stunning. I'm completely bowled over. The way you program the sound chip and got the bass going. I don't know what to say about that. Did you write all the music? Did you use anything to write the music and convert it, or did you just write its data statements? Because the music's stunning in it as well. Yeah.
I used Modplug Tracker initially with a set of kind of BBC sounding samples, and then converted that into data statements. I mean, the music was, I did write all the music myself. I don't think the actual compositions are particularly good, but they're good enough for the most part.
I think you're underselling yourself, there, Sarah. I think the music sounds great, and really the game as a whole is excellent. It's you using these sort of adjective reasonable. Everything's far more than reasonable with that game. It's a great achievement.
Yeah, it's an awesome game actually because it's cohesive. Everything really it's like a jigsaw puzzle that you've just completed. The great satisfaction to see that and play it. It's a wonderful game.
Thanks.
Do you think you're going to? Well, everyone probably want you to do another one at some stage. Would you do another one? Consider one?
Another game in general, or another White Lines?
Well, or another game, yeah, or something.
So I do have another game kind of planned, but I've just had a bit of talking far too early about my game, so I'm saying nothing about that one. It's not another shooter. I have considered doing a sequel to White Light. It would be master only, with hopefully more graphics. But I haven't. But it's a vague idea. I certainly haven't coded anything for that.
Yeah, how long does it take? How long would you say a project like that takes? I know it's how long's a piece of string, and how much work you put into it. But a few years, would you think?
I would say if I was doing it now again and I wasn't taking all the breaks I had last time, it would be done within a year. I think that's not unreasonable. I think a lot of the reason it took so long was trying to get an artist, and there were various false starts there before John came along.
Sarah, I missed the reason why it didn't work with MMFS.
It's because I trash all the file system workspace.
So why does it work with an ordinary disk drive then?
Because DFS is happy if the workspace is just 0.
So let's have a word with the guys who do MMFS and get them to sort it out.
The problem I remember when I looked into it is that it needs to store, because you've got a bunch of SSDs on a card. It has to store what number file it's looking at, and if that gets trashed, it then defaults back to 0, I think, or does it just end up with nothing mounted at all? I can't remember. But that's the underlying problem, I think.
So you need to put White Light on disk 0 then?
Maybe, unless I'm misremembering it, and you just don't get any disk.
You said that you would like to have put more alien patterns in. Is there anything else you'd like to have put into White Light? I'm assuming you got a bit burnt out towards the end.
Yeah, there were more. I did want more power-ups at one point, because I think part of the problem is with the because with your shots, the way they're drawn is you just sprite color free in a bunch of places. There's no actual graphics there, and I think that made it difficult to effectively implement many other kind of shot types, which would look distinct, which would look distinctive to the average player. And I did vaguely have plans of, kind of fancier stuff. So I kind of wanted to do something like the toothpaste laser from Raiden. But I quickly figured out there's no way you're going to do that on a Beeb.
It just costs too much out of the rest of the game.
Yeah.
A techie question on the. You said you implemented sort of crude mutex. So does that mean it's sort of re-entrant? Do you have to save? Save out contents of registers or anything like that. So
No, I mean, and basically what it is there's a is to ensure that the kind of sprite coordinate registers end up atomic. So the background rendering process can pick up a full copy of those in the knowledge they're not going to be modified in the middle. So effectively use disabling interrupts around the copy loop to make sure that doesn't happen. I think there's also a few places where we have to disable sprites. So again, there's some other magic going on there somewhere. It's been a while. I can't 100% remember the details, but I remember it being slightly painful to implement.
Okay. We've also got as well as many very positive and enthusiastic comments. A couple of questions. One that stands out here from Robert is: can you be persuaded to release the source code?
No, because then I'd have to clean it up, and then I might have to answer questions on it. And I tried digging through it while making this presentation, and really struggled to understand most of it myself. I think about this habit, I'm no good at structuring stuff in assembler, and I don't make enough comments, and my variable names are too short. And particularly on the beep, once you've had to cram everything into however little memory you have, it's utterly unreadable.
Surely that might be an idea to release it and let somebody sort it out for you.
Maybe, but I'd have to be bothered, and can't really quite be bothered.
Well, I wouldn't think you'd need to get involved, because I mean, if somebody's doing elite code and various other programs and sorting those out and annotating them, then they needn't bother you at all.
I'd always be tempted to see someone do an annotated disassembly, see if it's any more readable than my own coders.
Well, there's a challenge.
If no one else is going to pipe up, I've got another question, which is essentially around sort of learning to get this good at coding. So you say you're the token young person, Sarah. So when did you get into coding, and when did you? At what point did you think, right, I can write a game here in assembler?
Oh gosh, it's years and years. So I started coding in the kind of mid to late 90s, initially on QBasic on the PC, and then moved on to C, and then I got into started writing emulators, mainly because the Beeb ones at the time weren't that great. But I was 13 when I put the first version of BM out, so I mean, you can check that out for the whatever level of quality that is. But yeah, I mean, I do at some point have plans for a forthcoming talk on emulation and how it ruined my life. And I don't think it's hyperbole to say it probably did ruin my life a bit. But it did inadvertently give me, knowledge of machines like the Beeb and, reasonable skills in assembler and that kind of thing.
Yeah, again, a great understatement, I think. Definitely much evidence of a lot of knowledge with the multiple emulators and so on. So you wrote an emulator before you wrote a game?
Yes.
Wow, that's one way to go about learning.
Emulator in the game is, particularly if the emulator's a bit crap.
Well, I think you're very modest, that's all.
Do you have any more questions for Sarah?
I think someone was asking about releasing the level editor.
Oh yes, I missed that.
Oh, it's that Kieran bloke. I know him.
Well, if he's volunteering.
You'll see. We have to check the editor actually works on modern Windows.
I just wondered if whether there's rather than releasing the source code, but is there a way to get the kind of build system sufficient that you could fiddle with the assets and it would still make a sort of playable disc, and then somebody could perhaps make new levels and things like that? But I imagine that it could be quite difficult because they're often quite tied together and there can be dependencies and things. But just a thought, if the code was sort of...
Maybe it's something for me to think about.
Okay, yeah, and I've been asked to read a couple of the comments out here. So there's some great comments there. Great job, Sarah, and a brilliant game. Had lots of fun during beta testing. And someone concurring with me, underselling indeed. To finish a game is very hard to do, and so with such a great game, it's super tough. If elapsed time, I'm pretty sure you didn't spend 10 years contiguously putting that together.
It was in the back of my head for about 9 years. Kind of nagging guilt.
Yeah, I can relate to that. Yeah, and is other people saying, yeah, sort of, and respect to anyone actually finishing and releasing a game. I started countless games, but quickly lose interest, and so yeah, that is it. It does take stamina to get through to the end, and I think someone else said that yeah, the last 5% is tough.
And we were very fortunate enough to be able to have that the last Abug meeting, virtual Abug meeting, as one of the high score challenge games. So,
is there any way of listening to the music without playing the game? Unfortunately, I'm very rubbish at the game.
I keep getting asked this, and I keep forgetting to do anything about it. But I do intend at some point to track all the music up on YouTube.
Yeah, because it looks really interesting. Some of the tech sounds amazing, really, for the music. But unfortunately, I'm rubbish at the game, or I could cheat at the game, maybe.
I think I took the cheats out before it got released.
Yeah, that would be really interesting for me. But, yeah, great job.
Thanks.
Okay. Another late question. Sarah, could you maybe produce a demo disc for the Beeb containing the music tracks only?
I'm slightly concerned the recording PC has gained sentience.
I think that would be Arcadian, Dave.
Yeah.
He's a PC now.
He's got multiple machines on the go.
It's just nagged the PC so much, it's just decided to type it itself.
Fair enough.
One question, Sarah, what's next?
Beer.
I meant BBC-wise or Acorn-wise, programming, games, whatever.
Well, I've got a demo on the go for the Archimedes. That's being released at Nova in 2 weeks. And then, as I said before, there is another BBC game, but I'm keeping quiet on that at the moment, other than saying it exists.
So at which point I'll say, yeah, we'll wrap up Q&A for this presentation on White Light, and I'll even say thank you very much, Sarah. That was great for you to take us through all the effort that you did to make that great game. So thanks very much.
No problem.
Cheers.